In the name of God. Hello again, dear students. Welcome back to Ferkho's website. My name is Masoud. I'm a physics teacher. I'm at your service to solve the problem of section review 1.1, page 12. Question number 1, convert the following angles in degrees to radians. Right? We want to convert these, let's say, angles from degrees to radians. Right? The first one, A, 35 degree. We have 35 degree actually. Solution, which rule is convenient here? We have this rule. Delta theta in rad is equal to pi over 180 divided, multiplied by delta theta in degree. Just, let's say, just substitute 35 in place of delta theta, because this ratio is constant, right? The ratio of pi over 180 is a conversion factor. It's constant. So how do we calculate this? Pi takes 3.14 here, multiplied by 35, divided by 180, and the answer will be 0.61 rad. Let's move on to B, 128 degree, right? We want to solve it here by means of the same equation. We have the same fraction, pi over 180, multiplied by this, let's say, this time we have 128 substituted here, and multiply pi by 128. You find the number divided by 180 and becomes 2.23 rad. That's it. Let's move on to question number, another question. Question number 2, right? Let me read the question for you. Question number 2, it says, a mosquito lands on a phonograph record 5 centimeters from the center, from the record center. So there's a, for example, a phonograph, or there's a CD, anything. So like this, right? Like this CD, for example, there's a mosquito. It's like an analogy for this question. There's a mosquito. It lands on what? It lands on 5 centimeters from the record center. What does it mean? If let's say, if one insect sits here, right? What's the distance between the rim, between the position of the mosquito and the center of the CD, for example? What's this? Actually, it becomes the radius. So this is R, right? From the record center. So there's a mosquito here, and we have R. Right now, R is available. If the record turns clockwise means in this direction. Clockwise means negative direction, yeah? Negative. So that the mosquito travels along an arc length of 5 centimeters. So delta S, we have delta S, arc length means delta S, and it's negative, right? Delta S is negative because it says clockwise, because clockwise means it's in the same direction of clock hands. What's the mosquito's angular displacement? So what do we look for? We look for delta theta. We have R and we have delta S. The first equation in our textbook is used here actually. But here, let's say, dimensions are not unified, but you can, let's say, you can use them as they are, because they cancel out each other. That's why it doesn't need to, let's say, convert centimeter to meter. Delta theta is equal to delta S over R. This is the rule. Delta S means negative 5 divided by R, 5 centimeters. So both of these values are in centimeters. That's why they cancel out each other. delta theta is equal to negative 1 rad. That's it. And in this question, actually, we can, let's say, we can conclude that 1 rad, what's the meaning of 1 rad? Means 1 rad is an angle whose arc length, look here, whose arc length equals to its radius. So it's 1 radian is an arc length, is an angle whose arc length equals its radius. 5 is equal to 5. That's why. So this is a mathematical proof of the definition of 1 rad. Question number 3. A bicyclist rides along a circular track, right? If the bicyclist travels around exactly half the track means half the circle, right? Because it says it travels along a circular track, and this bicyclist travels half the path, half the track. Means this part, right? You take only the upper part of the circle from here till here, right? So what's the delta theta? Guess the delta theta for me. What's the angular displacement for the bicyclist? Delta theta is equal to pi rad. Because the full circle is equal to 2 pi rad, but the bicyclist only travels, let's say, half circle, right? In 10 seconds, so we have delta t as well. This is delta t. So right now we have delta theta and delta t. What's his average angular speed? What do we look for? Average angular speed means omega average. Is information available for finding omega average? Yes, right? But here it says 0.5 rev. Why do we say 0.5 rev? Because it says half the track. The bicyclist travels, let's say, half the circle. That's why it becomes 0.5 rev, and 1 rev becomes 2 pi is equal to pi rad. And you can use, let's say, pi rad directly without using, without elongating the, let's say, the solution. You can say pi radians directly. Delta t is equal to 10 seconds. We look for omega average. Write the equation. Just divide them by one another. Delta theta becomes pi, right? Because it doesn't mention, let's say, the direction. It doesn't mention it whether it's clockwise or counterclockwise. So take it as counterclockwise. Let's say deal with it as a positive direction. That's why we didn't mention any sign here. Pi, delta theta becomes pi, delta t becomes 10. So what value does the pi take actually? 3.14 or 180? I'm sure you know the answer because we have a rule here, and the rules, or let's say I told you, rules are devised only for rad. And for rad, we have 3.14 for pi, not 180. That's why 3.14 divided by 10 becomes 0.314 rad. That's it. Let's move on to another question. Let me read another question for you. Question number 4. So what's unknown here? Let me read the question for you. It says, find the angular acceleration. You see? So we look for angular acceleration. Do you know what the sign of angular acceleration is? Angular acceleration is alpha. So we look for alpha. Find the angular acceleration of a spinning amusement park ride that initially travels at this one. So we have omega initial of 0.5 rad per second, then accelerates to 0.6 rad per second. Accelerates here, it doesn't mean acceleration actually. This value is not acceleration. It says accelerate. It speeds up actually. It increases its velocity to what? To this value. That's why this one becomes omega f. Don't confuse. Don't say, teacher, it says accelerates means we have this, this number is acceleration. No, it's not acceleration, because at the beginning of the question it says find the acceleration, find the angular acceleration. That's why, and we have another point for recognizing the, let's say, the quantity, because we don't have any square for s here. Rad per second means this is the unit of angular speed, not angular acceleration. During 0.5 seconds, this is delta t. So we look for alpha, right? Alpha is unknown. Omega I is available. Omega f is given. Delta t is known, right? So by means of these information, I want you to tell me the convenient rule, right? I say maybe this rule works. Omega f is equal to omega I plus alpha delta t. Let's check the answer, right? Is this equation, let's say, different from this equation? No. So it's just rearranging of this equation. We just rearranged it, right? So this is the origin of this rule is this one. I wanted to bring omega I here, it becomes negative, and solve the problem, solve the equation for alpha. Alpha becomes omega f minus omega I divided by delta t. So this is the origin of this equation. It's not a new equation, it's a rearranging of one of the four kinematic equations. So alpha is equal to, and by the way, we don't have any conversion because the units are arranged, the units are unified. Omega final becomes 0.6, omega initial becomes 0.5 divided by delta t, 0.5 second. That's why 0.1 divided by 0.5 becomes 1 over 5, or 0.2, let's say rad per second squared. That's it. Let's move on to question number 5. Let me read the question for you. This is the last question of the, let's say, section review. And by solving this problem, let's say we reach the end of the section 1.1, let's say, of grade 12, actually, chapter 1. Let me read the question for you. It says, question number 5, what's the instantaneous angular speed? So what do we look for? Instantaneous angular speed of a spinning amusement park ride that accelerates from. Accelerates means it speeds up, right? I told you in 5 minutes ago, I told you about this, let's say, this term. Accelerates means it speeds up. From this value, so omega I, at a constant angular acceleration of, constant angular acceleration is alpha. We have alpha. Omega I is given. Delta t is known, and only we look for omega f. So which rule is convenient? The first rule. And actually, it's not an order for the rules. If you name any one of the rule by number 1 or number 2, as you like, no problem. There's no sequence for the kinematic equations. I use this rule actually, omega f is equal to omega I plus alpha delta t. Omega I becomes 0.5, just substitute it, plus alpha 0.2 multiplied by delta t, 1 second. And that's it. 0.2 multiplied by 1 becomes 0.2. This part becomes 0.2 plus 0.5 becomes 0.7 rad per second. That's all for today, guys. Thank you for watching this video, and bye-bye.